Today we're going to be factoring out the monomial. Don't forget, take notes as you go and do the survey at the end. We've been multiplying polynomials. Today we're going to work backwards. For example, we've started with multiplying something on the outside of parentheses and multiplying all the terms. And we end up with a nice polynomial with no multiplication. Now this time, we're going to start with something like 8x to the fourth minus 16x cubed plus 18x squared, and we're going to end up with the piece that has multiplication in it. To do this, we need to keep in mind the greatest common factor. So for our first example, we are going to take out the greatest common factor between 45 and 40. This would be 5. And then when I'm looking at my variables, I want to take out the common variable, the common letter, which would be v, and the lowest exponent between those, which would be 3. So then I say 45 divided by 5 is 9, and I'm going to subtract my exponents instead of add. So 4 minus 3 is just 1. Then 40 divided by 5 is 8. And when I subtract my exponents, 3 minus 3 is 0. So this one's done. Now, as you can see, if I were to multiply this back out, you would get 45 v to the fourth plus 40 v cubed, which is exactly what we started with. Okay? We're not looking for the blue answer. We're looking for the yellow answer. I'm just trying to show you that if you were to multiply it back out, you should get the same answer. Now, for example 2, what number divides 9, negative 90, and negative 18? Well, 9 is the largest number that divides that. So I'm going to pull out a 9, and then I've got an n in all three. So I'm going to take out an n, and the lowest exponent here is 1. So that's all I can take out. So 9 divided by 9 is 1, n to the fourth. Subtract our exponents. 4 minus 1 will be n cubed. Negative 90, be careful there, divided by 9 is negative 10. 3 minus 1, when I'm looking at exponents, is n squared. Negative 18 divided by 9 is negative 2. When you subtract your exponents, 1 minus 1 is 0. So now I'm left without a variable there, and this is my answer. Example 3. So we're getting much larger polynomials, but we still follow the same process. What is the greatest common factor of 63, 27, 45, and 45? Well, it's 9. So how many b's can I take out? Well, this one has a b, this one has a b, this one has a b, but this one does not. So you cannot take out a variable here. So 63 divided by 9 is 7. Keep your b cubed because we're not taking out variables. Negative 27 divided by 9 is negative 3. Keep the variables. 45 divided by 9 is 5. Keep the variable. And then 45 divided by 9 is 5. And this one's complete. For the fourth example, what comes out of negative 48, 56, and 64? Well, this would be 8. Now I look at my variables. This one has an x, this one has an x, and this one has an x. So I'm going to take out an x, and the lowest exponent is 1. They also share a y, and a y with the lowest exponent of 1. So then negative 48 divided by 8 is negative 6. And I subtract my exponents. 7 minus 1 is 6, so x to the 6th. 1 minus 1 makes our y's go away. 56 divided by 8 is 7. Then x cubed, so 3 minus 1 is x squared. My y's cancel because I have a 1 minus 1, so they don't exist anymore. Then 64 divided by 8 is 8. This time, I've got a 1 minus 1 on the x's, so my x's cancel. But on the y's, I have a 2 minus 1, so I've got 1 y there, and this is my solution. So things to remember. The greatest common factors include not only numbers, but the variables too. Once you get your answer, you can check it by looking at your terms in the parentheses and making sure there are no more common factors. Write the greatest common factor on the outside of the parentheses, and everything else goes into the middle. Make sure you watch your signs, and here are the survey questions in case you can't see them.